Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the development of the lateral surfaces of the solids using the Solid Edge software. In this problem statement, we have a hexagonal pyramid of base side 25 mm and height 60 mm, which is resting with its base on the HP, and an edge of this pyramid is inclined at an angle of 40 degrees to VP. Also, coming to the cutting plane, the truncated pyramid with the truncated surface indicated in the front view at a point on the axis 20 mm from the apex and is inclined at an angle of 40 degrees to XY line. We need to draw the projections of the pyramid and also show the development of the lateral surfaces of the remaining portion of the pyramid. So to understand this problem statement, so first we need to get the concept of two important points here. So the first one is the type of solid. So the type of solid here is a hexagonal pyramid, and also its resting condition. It is resting in such a way that one of its edges is inclined to VP at an angle of 40 degrees. So here neither the corner condition nor the edge condition will not apply, but one of its edges must be inclined at an angle of 40 degrees. So the simplest way is to construct a hexagon first and align one of its edges along a 40-degree line which is inclined to VP. And next is the cutting plane. So the cutting plane is passing through a point at a distance of 20 mm from the apex of this pyramid and is inclined at an angle of 40 degrees to the XY line. So this is the condition of the cutting plane. So these are the two concepts that we need to understand before we draft the solution. So now let us see how to draft the solution. So let us begin by selecting the line option. Select a line of thickness 0.18 mm and draw the line of any arbitrary length, and let this line be the xy line. Now let us select a line of thickness 0.13, and we all know that the plane above the xy line is the vertical plane and the plane below the line here is the horizontal plane, that is HP. So now we need to draw a line which is inclined at an angle of 40 degrees to the VP. So let us draw a line of any arbitrary length, but the angle shall be equal to 40 degrees. So just go to the angle between and select this line and this reference line. So you can just see that this is a 40-degree line. So on this line, we need to place one of the edges of the hexagonal pyramid. So for that, again, let us go to the line option, construct the pyramid. So the pyramid is having its base edge of 25 mm. So the first angle is 0, followed by the base edge of 25, and the next angle being 60 degrees, followed by 25, and the angle being 60 into 2. Next, 25 and the angle being 60 into 3. Again, 25 and the angle being 60 into 4. And then complete the hexagon by drawing a line of length 25 mm and the angle of 60 into 5, or just minus 60 degrees. So now this completes the hexagon. So now select this hexagon, go to the move option, and just select any one point of the edge that has to be inclined and place it on this 40-degree line. So you can just see this. You can use the zoom in option. So I'm placing one of the corner on the 40-degree line. Now let me select the rotate option. This is the first point of rotation. This is the second point of rotation. And I'm rotating the entire hexagon. So this particular edge in such a way that it is aligned on this 40-degree line. So now just use the move option again and then drag this hexagon on this 40-degree line. So let us just zoom out. So this completes the placing of the hexagonal pyramid. So this is the base of the hexagonal pyramid. So now let us draw the triangular faces. So select the line option and join the opposite corners. You get the 6 triangular faces of the hexagonal pyramid. So now let us go for completing the front view of this particular pyramid. So draw the projection lines from each of the corners and intersect the same with the XY line. Also from the axis, so you can just see that the axis will also be a unique line. It is not intersecting with any of the corners. So now select a line of 0.13 mm thickness again. Now select the axis line. So from here, draw the axis which is measuring 60 mm as given in the problem statement. So this is the axis of the hexagonal pyramid. Now again get back to the continuous line. Join the apex of the pyramid to the end point of these projection lines to the apex. So repeat this for all the points that is intersecting the XY line. So this completes the top and the front views of the hexagonal pyramid as given in the problem statement. So go for the smart dimension, measure the axis length which is equal to 60 and show the dimension of any one of the edges of the hexagonal pyramid which is equal to 25 mm. So now we'll go for annotation. Select the text option from the annotation menu. So first let us annotate the reference line as x and y. So this is x and this is y. Also let us annotate the reference planes. So this is VP and this is HP. Let us annotate the corners of the hexagonal pyramid. So let us start from this corner. Let us call this as the corner A, corner B, corner C, corner D, corner E, and then corner F. So this is the apex of the pyramid, which is O, and inside the bracket it will be O1, which is the center of the base of the pyramid. So here this is again the apex O dash in the front view. This is the corner A dash. So this will be the corner A dash. This will be the corner B dash. This is the corner C dash, and this, okay, so this is corner C dash. This will be F dash. This is E dash, and this corner will be D dash. So these are the 6 corners of the hexagonal pyramid. So this is the front view, and we have also annotated the corner points in the top view. So now let us go for constructing the cutting plane. So the cutting plane is having a dimension of passing through a point which is at a distance of 20 mm from the axis and is making an angle of 40 degrees to the xy line. So this is the condition. So now what we can do is I'll select the line option. So this is the axis line, this is the apex. So from here I'll drop a line which is measuring 20 mm. So you can go for the smart dimension, select only this portion of the line and then show the dimension which is equal to 20 mm. Let me select the line option again. So select the line type of the cutting plane. So from this point, let me draw a line making an angle of 40 degrees with respect to the XY line. Use the extend to next option and extend this line in such a way that it is cutting all the slant edges of the pyramid. So now go for the trim option. So trim this portion. So go for the angle between. So the angle between this cutting plane and also the base of the pyramid will be equal to how much? 40 degrees as given in the problem statement. So this is the cutting plane. So the next parameter is none of the slant edges are parallel to the xy line. So none of these slant edges can be assumed as the true slant edge. So what we can do is we will draw a line from the apex which is parallel to the xy line. So from the apex, draw a line parallel to the xy line. So the nearest slant edge to this line is OD. So go for arc by center point. Select this OD as the radii and then cut an arc such a way that it is intersecting this line which is parallel to the xy line. So now this point will be D1. So this slant edge, that is OD1, will be assumed to be parallel to the xy line. So again, go for the line option. From the endpoint of this arc, draw a projection line and connect its endpoint to the apex. So this will be O dash D1 dash, and that will be the true slant edge. So go for annotation, annotate this point as D1 dash, and here O dash D1 dash will be the true slant edge which will be considered for constructing the arc. So now let us highlight the portion of the truncated pyramid. So select the line of thickness 0.50. So this portion of the pyramid. So highlight all the slant edges, the base of the pyramid. Do not select the true slant edge. That is only the reference edge to draw the development. So this edge is again darkened. And again from this point of intersection, join it to the corner point, point of intersection to the end point. And next we have got one more slant edge, that is O dash A dash. So from the point of intersection, join the base of the pyramid. So these are the points. So now let us go for annotating the points. So the first slant edge is O dash A dash. Let us tell this point as 1 dash. And next slant edge is O dash B dash. Call this as 2 dash. And next we have got O dash to C dash. And let that be the point 3 dash. Next after C we have got D. So O dash D dash is the point 4 dash. So this is the point 4 dash. And next we have got O dash E dash, and O dash E dash will be the point 5. So this is the point 5 dash in the top view. And the final slant edge is O dash F dash, and that is intersected by the cutting plane at the point 6 dash. So these are the points. So now the next procedure is select the line of thickness 0.13, transfer all these to the true slant edge. So point 1 is transferred, point 2 is transferred, point 3 is transferred, next 4 is transferred, next we have got the point 5, transfer the point 5. So all these lines will be exactly parallel to the xy line. So point 6 is also transferred. So we can take the measurements of these to mark the points on the development of the hexagonal pyramid. So now since all the points will lie on the true slant edges, I can just indicate all the points as 1, 2, 3 along the corners, and the entire pyramid could be highlighted using the line of thickness 0.50 mm. So this is zero point 0.5 and then 6 on OF. So this is the 0.6. Let me select the line option again. So let it be a line of thickness 0.50. So highlight the entire pyramid along with its triangular faces. So now we need to measure the dimension of the true slant edge to draw the arc. So now let me select this line. So it is measuring 65 mm. So let us sweep an arc of radii 65 mm. So select the arc by center point. Select the line of thickness 0.13. So from any arbitrary point towards the right hand side, let us just sweep an arc of radii 65 mm. So this is the radii of the arc. Now select the line option, join one end to the point, that is the center point of the arc, and from that point start cutting the arcs of 6 numbers measuring 25 mm. So the radii is 25. So this is the first part. From the point of intersection, again sweep a radii of length 25 mm. So select the point of intersection, sweep a radii of 25. So repeat this step 6 times to get the 6 equal parts of the hexagonal pyramid. So now we have got the points ready. So select the line option, select the point of intersection of this arc and the main arc, and join it to the center point of the main arc. So always refer the point of intersection so that you get the exact points. So now join the bases of each of the triangular faces using the straight line. So this completes the initial position of the cut section of the entire pyramid. Use the trim option to trim the remaining portion of the arc and also the arcs that were used for the construction of these slant edges. So use the zoom in options properly. If you're not trimming these points, then whenever we are marking the points on the slant edges, we might get confused. So it is better to remove all these arcs. So now go for distance between. Select the apex, and then the point 1 is here, which is on OA. So we need to draw a line of length 32.27. Go for the line option. So before we start, let us annotate. So this is the apex O of the pyramid, followed by the 6 corners A, B, C, D, E, F, and then back to A. So now let us draw a line of length 32.27. So from O, draw a line of length 32.27. So this is one point, that is the point 1, and here also we need to mark the same length 32.27. Again go for the distance between, select the apex and the point 2 on the slant edge, and that will be equal to 29.59. So go for the line option, draw a line of length 29.59. So I've got the point 2. Next, distance between, select O dash and the point 3 dash, that is on the slant edge, O dash C dash, and that is equal to 23.07. So line option, draw a line of length 23.07. So I've got the point 3. Next, distance between O dash and the point 4 dash is here. So you have to generously use the zoom in options. You'll get the dimension as 17.09. So go for the line option. On OD, draw a line of length 17.09. And next, we need to mark the point 5 and 6. So go repeat the steps. Select O dash and the point 5 dash is here. Okay, so this was 5 dash, which is equal to 17.09. So we need to redo the point 4 dash. So just go for the distance between, select O dash, and this is the point 4 dash. So this is equal to 16.31. So go for the trim option and trim this line on the, or just select this line. It shows the dimension here, that was equal to 23.07. So change that to 16.31. That is the point 3 on OC, correct? Okay, we changed it on OD. So just undo this. So this is 23.07. That is for point 3 on OC. So now point 4. So change this to 16.31. That is on OD. So now go for the line option. On OE, I need to draw a line of length 17.09. 17.09. So next on OF, that is distance between O dash. So let me select 6 dash. Okay, so we have not drawn that parallel to the XY line. So from the point 6, okay, the point is here. Okay, so the point 3 is having an error in this sketch. So okay, not an issue. So what you can do is measure 0 to 3. So we'll be getting a dimension of 20.43, and 0 O dash to 6 dash is equal to 23.07. So just we'll swap the dimension. So select, so 3 is on OC. So change this to 20.43, and then go for the line option again. On the OF line, draw a line of length 23.07. So this is how you can just overcome the mistakes. So a keen observation is required. Now go for a line of thickness 0.50. So start connecting the points 1, and then just move the cursor, you'll get the end point. So select all the points. So this is the top portion of the truncated pyramid. So now let us join them to the base edges and also join the slant edges to the respective points, and then complete the development. So this completes the development. Go for the annotation and annotate the points. This is point 1, 2, 3, 4, 5, 6, and back to point 1. So you can just write the text development, indicating that this portion is the development of the hexagonal pyramid for the given condition. So show the dimensions here. Go for the smart dimension. Just show the dimension of the radii. So select distance between better A and O, which is equal to 65. So let us keep it neat. Do not make it overcrowded. So select point D and E. Show the dimension as 25. So with this, we complete drafting the solution for the given problem statement, wherein we had a hexagonal pyramid with one of its edges inclined at an angle of 40 degrees with respect to the VP, and the cutting plane passing at a distance of 20 mm from the apex and making an angle of 40 degrees with respect to the vertical plane or the XY line, with respect to the horizontal plane or the XY line. So with this, we complete the drafting for the given problem statement. Thank you all for watching.